First thing what we'll do is we'll talk about the basic things, okay? Like uh, here, let's go to
இதெல்லாம் ஃபர்ஸ்ட் டைம் லீவ் எடுத்திருக்கேன் அதுவும் அவன் சொல்ற சுச்சுவேஷன் புரியலையா நீங்க அவங்களுக்கு எக்ஸ்பீரியன்ஸ் இருக்கும்டா
right for me the date is also
இவ்வளவு
slow.
சரியில்லை
Go to net app. So initially what I'll do, uh, you guys have to mute it, okay? So initially what I'll do is I'll talk about the SAN and NAS architecture, the front-end port, back-end ports, this performance analysis, zoning, SAN switch troubleshooting, okay? All these things I'll talk about. Then I'll go into the NetApp, then initially NetApp architecture, then how the read and write happens in NetApp. Then I'll go into the networking part and other things, okay, networking part and other things. So let me just tell you the basics, okay. So basically what you have to understand is that there are many types of storage, okay. You have DAS, you have SAN, you have NAS, you have object storage, you have cloud storage, you have hyperconverged, okay, ACI. So here the first thing, let us talk about the first thing, DAS. So here what happened, the storage will be directly connected to the server or host, okay, storage will be directly connected to the server or host, okay. So basically the storage that is connected to the server, it can be internal storage or it can be external storage. Internal storage means suppose you have, just one second, just give me one second. So basically what do you mean by internal storage? Internal storage means suppose you have bought CSQ blade, maybe you have something like Nutanix or something, and you are having the storage attached to it internally, okay, so that is internal. Like you are having hard disk for your HP servers, right? So those are internal. External means you are having some external storage but it is directly connected to the host, there is no SAN switch in between them, okay, so that is DAS, direct attached storage. Prior to 2009 or 2007 it was very much in use, but there are certain limitations because redundancy, also the performance, those things, it's not good. And then SAN came, right? The SAN is the one which is like, from the performance point of view, it is mostly used, okay. SAN, what is DAS? DAS is direct attached storage. SAN is storage area network, okay. Okay, so basically what in SAN, what you do, use the fiber cables, use the high performance FC switches, okay. And what happens is that between the server, like you connect the storage front end port, okay. So let me show you, let me just try to explain this, okay. Let me go to the images. I just wanted to show you something, okay. Yeah, let me go here, okay. See, so this is your daily MC, okay. You can this can be anything, NetApp also. So what you're having, it's a 2 node cluster, and these are all FC ports, fiber channel ports, okay. This is your switch, fiber channel switch. So normally whenever you're using SAN, you'll have at least 2 fabrics, dual fabrics. Why? Because whenever you're working as a storage admin or infra admin, wherever you are working, you have to make sure there are no single point of failure. If you have one switch and that switch is down, then that is gone. Here, although it is showing as one switch, right, it's not really one switch, it's basically fabric. Fabric means collection of many switches, okay. And there are two different type of fabric, I'll also explain that to you, okay. Core edge fabric and full mesh, partial mesh. So basically what you can see here, from controller 1 you're connecting the FC port to this fabric. Controller 2 you're connecting here, okay? And then here you have the ESXi host, okay? VMware. These are ESXi host, okay? And it is having HBA host bus adapters, and you're connecting the HBA to the switch, you're connecting the front end port to the switch, and you are doing the zoning between them, okay? So that's what you are doing. And what is happening? It is happening block level communication, SCSI communication, okay? So what is happening? Because you have two fabrics, so there is high availability and scalability. So why scalability? Because you can add on more switches, you can get more ports, okay? And the performance is good because the FC cables, they transfer like, you know, like single mode, multi-mode FC cables are there, right? So the speed transfer is good, okay? They give you better IOPS, better throughput, okay? So you're getting this, and performance is much better compared to DAS. Availability is also better, so you're getting a lot of things. Because why its scalability is better? Because in DAS what you're doing, if you're using external storage like this, you're connecting this port directly to the host, right? So this host is using this port, and this port is not able, you cannot use this port for any other host, okay? Because this is that, in that case you are doing DAS connection, okay? Like let me show you DAS storage. These are all theoretical. First part will be theoretical, then I'll go into the hands-on. Don't worry, everything that I, you know, in the syllabus, everything that is mentioned in the syllabus, right? ADP, advanced die partitioning, networking, NFS, CRFS, NVMe, on-tap upgrade, AIQ, Occam, alerts and all, system configuration or backup configurations, snapdragon vault, everything I'll do practically. Don't worry about that. Okay? So, and then we'll go into L3 session, but first I need to, you know, because many people might not be maybe from some different domain, right? So I need to clear the basics. So now you see the dash, right? So let me just take a good thing. Yeah, here. So what you can see, this is a dash, right? So this is your storage, this is your server. You're connecting directly, no switch in between, right? So the ports are getting wasted, right? So the ports are basically getting wasted, okay? The ports are getting wasted. But in case of SAN, what we are having in case of SAN? Let me show you some other picture. This is good enough. So in case of SAN, what is happening? You are having multiple switches. So I'll also explain details. So basically in Fabric, what we use, you can either use Cisco switch or Brocket switch, okay? But there is a concept. The concept name is core edge fabric, okay? Core edge fabric. Somebody ping me, I don't know who. Okay. So core edge fabric, right? Core edge fabric means what? What do you mean by core edge fabric? What do you mean by core edge fabric? Let me show you that picture, okay? So that I can make you understand. 1 second. Yeah, this is better. This is better picture. Little bit of more things are there. Yeah, this is better picture. Okay. So in core edge fabric, what we do normally? Core means this is core, okay? Edge means this is edge. So at the core of the fabric, we have the director switches. Director switches means the switches which are more expensive, which is having lot of ports, which are hot swappable. That means if you have any faulty hardwares, without shutting down the switch, you can replace it online, okay? And then we have the edge switches. These edge switches are basically fixed port switches. So we have fixed ports. So basically what we do, we connect the storage front end port with the core switches, director switches, and we connect the host to the edge switches, okay? And then if you want to expand the fabric, what you do, we buy more edge switches, and we create ISL connection between the edge switch and the core switch. So what we have is, we'll have edge switch and core switch, right? So we'll at least get two paths. Why two paths? Because we want redundancy. If one path is gone, then we have another path, and also we want better speed. Suppose one port, one fabric port, one switch port supports 30 Gbps. Okay, so if you have two path, right, and you do trunking between them, then you will get 64 Gbps speed. Okay, so what I need to say is, switch port 32 Gbps. Okay, so trunk port, okay, 64 Gbps. I will explain the switch classes, right? I will tell you how to do trunking and everything, but it's included in the NetApp training. So what we normally do in the trunking is, let me show you the picture, okay? You can understand. These are the questions they'll ask you, whether you have more experience or less experience, that what is fabric? You have to say collection of switches. Fabric. You will have both the fabric. Okay? So those things, trunking, switch trunking, let's see, switch trunking, SAN, switch trunking. 1 second. Second. Here, yeah, this is a little bit better. This is little bit right. The problem, they don't give you much actually, but anyway. So this is what I wanted to say. Okay, you can see the right two ISLs, right? Two ISL ports, right? So I'll tell you what are ISL ports, different type of switch ports. Okay, E, F, G, EX, E. I'll tell you. So basically, just we need to use ISL to expand the fabric, to create a fabric. If you have one switch, some environment will have one switch, but mostly you will have many switches. So to create a fabric, you have to connect to the switch using the ISL connections. Okay, and there are different things. I will tell you, virtual ISL and physical ISL. Okay, I will tell you that, LSAN and all. But what we are doing here, I am connecting two FC cable from one switch to another switch, right? And then what I'm doing, one path is, this one port is having 32 Gbps speed. So two ports, if we aggregate together, if we do link aggregation, then what will happen? The speed will be 64 Gbps. But there is a limitation in SAN switch. So there is a concept like octet. Okay, so 0 to 7 is octet 1, and behind octet we have ASIC. Okay, so what does it mean? If you want to create trunking, then you have to choose two ports in the same octet. If you choose the ports from different octet, then your trunking configuration will fail. I'll show you how to do that, okay, in my switch classes. So what I was talking about SAN, right? Okay, SAN. Okay, so here what they're doing, these are all cluster nodes, you know, these are Oracle servers, like something. So this is fabric A, fabric B, you're connecting this. So this is basically SAN, storage area network. So in SAN, what you require SAN switches. Okay, now let us come to NAS. This is NAS, means the full form NAS is network attached storage. Network means what? Network means Ethernet, LAN network, LAN switches, Ethernet switches, not SAN switches. So if you have an existing environment, what you have your NAS, like your Ethernet switches, right? And your client wants you to give you some centralized share or something, right? So better to go with NAS if you do not have any performance requirement, because in NAS the data communication happens over the network, over the LAN, over the Ethernet switches. Okay. Okay, so that means the performance will be inferior compared to SAN. In SAN there is two more things. A lot of things I will tell you. You have FC, you have I, SC, SI, iSCSI. Okay, FC means fiber channel, WLPN number. iSCSI is network switches, IQ number. Okay, I'll explain to you these things when I configure these things in the net app. So in iSCSI, if you are using iSCSI protocol, you will be using block network, block level storage only, but you will be sending this block communications or the SCSI command over the network switches, not the SAN switches. So your budget decreases. You do not have to spend lakhs and lakhs of money because you already have your network switches. You need to use your existing switches. No need to purchase FC switches, but the performance is inferior. Okay. But there are certain situations for non-critical applications or the applications which does not require very good performance or lower latency. Okay, so at that time you can use iSCSI. Okay, now we'll talk about NAS. NAS is network, right? So NAS is what? It's basically a dedicated storage for applications that requires file storage. Suppose you're using ESX server, you want to create thousands of VMs. So what you need to do, you need to keep some storage, allocate some storage to ESX server. You can zone the ESX HBA to your storage front-end port and you can give it to them, allocate them as part of FC. Or what you can do is, you can also give NFS, like some NFS export you can do, and from the NFS you can create the data store. Okay, that is also possible. Okay, there is one more thing I forgot to say, SDS, software defined storage. Okay, so what we are doing here in NAS, so basically it's a dedicated file storage. Okay, so in SAN what we are having, we are using the SAN switches, right? But NAS not required. We are using network switches, and it is applicable only for the applications that does not require lower latency, and the applications which are using actually file server applications. Okay, suppose you're working for a banking client, they have a lot of financial teams. Okay, finance teams, HR teams, so they want to put some Excel sheets or some policy documents in a centralized position. So in that case you do not need to spend money, you can just make use of either NAS or iSCSI. Okay, so you're able to understand these things, right?
Yes.
Yes.
What I'm talking about, you're able to understand, right? Yeah, it's very easy actually. Then you have object storage, S3, storage simple service, 3SS, object storage. Now object storage, what you do, you have your files can be media files, it can be Excels, PDFs, lot of things, right? So what you need to do, you need to create a bucket. Okay, and you are just dumping those objects there. So it is totally unstructured, but it is actually like it can have like geopolitical or dispersed locations. So you can have it like, okay, so suppose you have something in Mumbai, you want to share to Ireland, right? So it's better to use object storage for that. Okay, like in cloud you are using Amazon like AWS S3, right, or Azure blob storage, right? So whenever you're putting files there, right, it depends on the region. Suppose you're in India, you're doing that, but your region is Virginia, then the data is not in India, the data is in US. Okay, and that is the reason the financial applications or the financial clients, they have the traditional infrastructure. So as per the, because of the standard or the audit, like SOX apply, like SOX compliance issues, they want to, they need to keep the data in their own country. So what they do, in the they use the traditional infrastructure, traditional data center, and they keep the file in their own data centers rather than keeping it on the cloud. Okay, because cloud you don't know where the data will be. Okay, and you have converged platform like Nutanix, Simplicity, FlexPod, pod V block. Okay, so that means you will have your storage, network, server. Server means compute, everything bundled together. Everything will be sold to you as part of complete package, combo package. Okay, the V block was their name. See, I did work on that package 2016. It was little bit difficult to work with, but it is a failed product. FlexPod is still used somewhere, but Nutanix is a very good product. It's been used. Okay, it has been used in many companies. Okay, and then you have one more thing, cloud storage. Okay, so NetApp has collaborated with multiple vendors, like cloud vendors like AWS, Azure, GCP, Alibaba. Okay, and what they did with AWS is they create FSx on tap, AWS FSx on tap, and in AWS FSx on tap, whatever NetApp function you have, like Snap Mirror, Vault, Snap Clone, NFS Export, all these things you can do in AWS because of NetApp collaboration with AWS. And for Azure, they have a product which is called as Azure NetApp Files. All these things I'll show you practically. In the last page, you can see GCP I have shown end to end. Everything in GCP I have shown. Okay, even the DR part also have shown the GCP. You can check my playlist. Okay, in this batch I will show AWS and Azure. So Azure is having two things like Azure Blob, but that is not made with collaboration with NetApp. With collaboration with NetApp, they have created Azure NetApp Files. It's a file product for CIFS and NFS. Okay, it's not a block product. And then you have your GCP NetApp volumes, for which you need the NetApp API to be installed in GCP CLI. Okay, or through the GCP Cloud Console, Cloud Shell. Okay, so what we are doing is NetApp is collaborating with multiple vendors and they are just expanding their same features to cloud. It is very easy to migrate the data from your on-premise NetApp to cloud or create applications between them. I will show you how to do that. Okay, and then you have another thing which is my favorite, that is software defined storage array. Let me give you an user case. Suppose you have spent crores of money on Hitachi storage and you do not have any budget left to buy your file storage. Okay, you have bought block storage, you have bought FC nice curly. Okay, but you do not have the money to buy a NAS storage. You do not have the money. So what you do, you just spend little amount of money with NetApp and just get some license for the on-tap select. On-tap select is a software defined storage array. Okay, so what is this basically? It is basically nothing but it's just a software. What you need to do, you need to go to the NetApp support site. You need to download a OVA file. OVA file, OVA or OVA. Okay. OVA, I think OVA file. OVA file is nothing but it's a template, VM template, using which you can create a VM. So what it will do, using the OVA template, you will create on-tap deploy VM. Okay, and from the on-tap deploy, you will be able to create the on-tap select cluster, software defined NetApp cluster. So what I normally do is I allocate my Hitachi storage. I zone Hitachi front-end port with my ESX servers HBA. I zone PowerMax, directed ports, front-end ports with my ESX servers HBA, and then I allocate either from Hitachi or from EMC. Okay, and then I create a data store in the ESX environment. And then what I do, from the on-tap deploy software, I add the ESX server and the vCenter admin credentials, it's a generic credentials there, and then from there I create the software defined storage cluster, and then I can use NAS from there. So although I did not purchase any NAS product, I'm still able to convert the SAN to NAS. Okay, and it is only possible because of the NetApp's software defined storage solutions. Okay, So for the L3 guys, I'll show you how to install the software like on tap select and everything, and what are the troubleshooting we do. For the L2 guys, also a lot of troubleshooting videos will be there. You need to study these troubleshooting videos to clear the interviews. And the videos, the troubleshooting I have explained, it is for the past 14 years what have I done. The recent one I'll keep on adding. Why? Because right now I got an issue, okay? Like not now, like in this week, okay? So I will discuss about that. And I also discuss how did I solve that. So these things will help you to get a job. Why? Because when you discuss the kind issue, right? So they will think, okay, this guy cannot learn this from Udemy, right? Or maybe from YouTube, or maybe the documentation, right? So he has really worked. By knowing the troubleshooting scenarios, they can understand whether you have worked or not. Okay. So what in infrastructure, in data center, there are many elements. Okay, in data center you have many elements. You have your database, you have your Oracle database, you have your SQL database, you have some kind of applications. Okay, the database can be structured, unstructured. Structure means SQL, Oracle. Unstructured is MongoDB, Redis. Okay, MariaDB. Okay, you'll have some compute. Compute means different servers like Linux, AIX. I don't know whether HPX is there or not. Okay, those things. Okay, Hadoop also you'll have. Okay, and then you'll have network, right? Network switches and all for the NAS, and then you have storage, either SAN or NAS, right? So those components you'll have in data center. These are the components you'll have in data center. And why I'm talking about this, because some people they need to understand, right? And after 4-5 batches, because I'm getting on tap AI, right? NetApp AI, I'll also teach you how to configure your cluster from NetApp AI. Data center architecture or data center components, whatever it is. Components. Anyway, it's not showing much. Data center components. Yeah. This is still okay. Still okay. We can make use of it. So you see servers are compute. The servers can be your physical servers, like you have your Cisco sales blade. There you have installed some bare metal. Physical servers means bare metal. Okay, you need to know this term. Bare metal. Okay, and you may have some cloud servers like Azure VM, AWS EC2 servers. Okay, and you have storage. The storage, the external storage, it can be SAN, it can be NAS, it can be object. For SAN, it's like AFF or FAS array. Okay, in data, I'm talking about AFF. Okay, AFF means all flash. Every disk using SSD or FMD, or you have FAS. It's a hybrid array. You'll mix of mechanical drives and flash drives. I'll talk about drives also and IOPS calculation and everything. We'll go one by one. Okay, and okay, so you'll have your FAS. So you have your SAN, you have your NAS, you have the object storage. The object storage in Hitachi you'll have your HCP. Okay, for NetApp you have either ONTAP S3, which you can get with AFM and FAS. Okay, or you have your storage tray, it is separate. Okay, okay, and then you have networking part, because for NAS you need the networking, right? Or for some other purpose also you need the networking, right? So you will always have networking. Okay, and you will have some monitoring devices like SolarWind, some other devices just for the monitoring. Okay, so what I do in my environment, I have configured the Occam. Okay, and I have created some SNMP traps which will be sent to the SolarWind, and the SolarWind will create tickets based on the severities that I have asked them to set. Okay, and these are the cabling in the data center, cabling that will be done by the data center. Battery power backup, so they will do like quarterly maintenance activities, power maintenance, to see that whether there is an earthquake or some power failure, whether they will be able to cope up with that disaster or not. the cooling feature you'll have in the data center. These are all applications. So these are basically data center components. Okay, you have to know this data center components. So in data center, what is our primary goal? Our primary goal is availability. Under no circumstances we should have single point of failure. To eradicate single point of failure, we need to have dual fabrics. We need to use dual HBS, dual front end ports, application level clustering, host level clustering. Host level clustering means Microsoft cluster, MS cluster, SQL cluster, Azure cluster, HCMP cluster, Veritas cluster, Linux cluster, Congalucy, which is called as Congalucy. I also worked on DevOps part for the NetApp, Trident software. I'll give you an overview on that, okay? So DevOps teams will also come to you for some troubleshooting issues. I'll discuss that. I'll upload a session on that, okay? So what DevOps team will do, if they're using Kubernetes, they'll create some deployment file, service file, right? And in that file, they'll use persistent storage, which will be given from NetApp. And they will get issues. I will tell you how to troubleshoot that. Okay, as a storage admin, we also need to troubleshoot because we have to troubleshoot whatever errors we get for the storage part. Okay, so in data center or in traditional infrastructure or any infrastructure, what is our primary goal? Availability, high availability, capacity. We have it should be scalable. We need to, suppose we want more space, we add more disk. Scalability should be there. Okay, performance, we should get optimal performance as per the application requirement. Security, it should be secure from the ransomware. I'll do a session on ransomware protection for NetApp. There are some configuration we need to do. Okay, so these things is there. Okay, data integrity, corruption should be not there. So what you need to do, suppose some data corruption happen, right? So you can restore from backup, you can restore from your local backup in storage, which is called as snapshots. You can restore from remote replica, which is like SnapMirror, SVMDR, Metro Cluster, SnapMirror Business Continuity, cross-grid applications. So these are all the things I'll show you. Okay, and volume level SnapMirror. Okay, these things I'll configure and show you. Okay, so data integrity should be there. If you have corruptions, you should have the disaster recovery mechanism in place so you can restore the data from your backup or storage. Okay, and also you have another thing, flex clone, flex slash, which also I will discuss and configure. LS mirror, there are a lot of things are there. So these are the things you need to know, and monitoring and reporting is very important. So as part of, suppose somebody is a L1 admin or L2 admin, right? So what they need to do, they need to create health checks, right? Health checks means you need to have a centralized monitoring like Occam in place, or you can log into each and every array, check for alerts, disk failure, something. Okay, and what you can do, you can prepare a list and send it to your client that disk has failed, we raised an SR, or power has failed. Some people are really bad, bro. You know, there's one person, he's been calling me for months, right? So I told him that 8 o'clock I will be doing the training, right? Still he's calling me. Very bad. So anyway, so what I'm trying to say is, you have to understand that you need to have monitoring in place, because you need to monitor the health checks, prepare a report and send it to your client. Okay, and if you have automated monitoring like we have, right? For automated monitoring, there are some tools like Occam tool. Okay, which as a storage admin we need to install. I'll show you how to install Occam and what are the errors we get during the installation time or addition when we try to add the NetApp cluster in the Occam. What are the issues we get? Okay, I'll discuss that. And we have for Hitachi, we have HiTrack, right? So these tools are very much important. Okay, because sometimes the client might ask you to get some performance data for some specific or custom window. We need to give him that. They want to do the capacity forecasting. You might have capacity forecasting meeting every month, so you need to find out the data. I used SolarWind and normal system manager to get the data for NetApp. For Hitachi, I use some IQ tool is there. Okay, in Hitachi I use that. Okay. So these are the things you need to know. So the capacity planning is very much important. Capacity forecasting, very much important. Okay. And there is one more thing you have to understand. That is life cycle management. Life cycle management. So I will discuss how to upgrade your on-tap arrays, how to upgrade storage grid, how to upgrade Occam, how to upgrade SAN nav, which is like the switch part, how to upgrade SAN switch, because upgrade is very much required. You have to understand when you try to somebody join, right? Please accept that person. So when you are working as a storage admin, your goal is to keep the environment devoid of any bugs. And how do you do that? How do you ensure that? For that you have to every quarterly you have to keep on upgrading your storage to a stable n-1 version. And if it's a tool like SANAP, Occam, then what you need to do? You need to upgrade to the latest version, not the n-1. So storage tools needs to be updated to the latest version. Okay, and storage needs to be upgraded to the n-1 version. I'll tell you, I'll give you a story. We recently upgraded the Hitachi array. Again some bug came, the power failure bug came, and again we need to upgrade. And we upgraded like last 2 weeks ago only. Again we got an error. Again we need to upgrade. There's a bug there. So that's a Hitachi is very good array. Like you do not have bugs. This is the first time I'm seeing probably. But NetApp will have a lot of bugs. And that's the reason if some storage is having bugs, right, that means they require the storage admins. You should not go to a storage where there is nothing is going on. You are easily replaceable. Okay, so that's why lifecycle management is very important. Okay, so lifecycle management in backup is like some retention period will be there, right, for snapshots. And suppose you are keeping 5 weekly snapshots, 2 monthly snapshots, 7 daily snapshot, right? So when you get the 8th snapshot, then the oldest snapshot will be deleted. You have a concept like delete order. The delete order can be oldest, it can be newest. So by default the delete order is oldest. You can change it. That means the oldest snapshots will be deleted. Okay. So those things comes under life cycle management policies. Okay, you have to keep on, you have to configure that. Okay. So in DR activity, right? So one more thing you have to understand, as part of storage admin, we have to do DR testing every quarterly, sometimes like yearly, or it can be a half monthly exercise also. So there what we do, you have the setup, right? You have the replication setup, either synchronous or asynchronous. Then what we do, we try to use the DR storage to mount it to some applications and try to see that whether you're getting the same data as we are getting the prod, and for the applications we can up the applications using the DR storage data, right? Then what we do, we sync the data from production to DR. See, for the DR testing, we never do reverse tracing. We never do sync from the DR to prod. Why? Because it's just testing. It's not real disaster. Only in real disaster reversing the data. Okay. So I'll show this DR testing method for SnapMirror SVM DR. In my environment, 3 years ago, what happened? We have the software defined storage, right? Somebody by mistake deleted that on-tap deploy, and because of some bug we had to upgrade the VHBA NIC, virtual HBA. Why virtual HBA? Because as I said, let me drink some water. As I said, the software defined storage array, the on-tap select node is basically VMs. VM is having VHBA, virtual HBA. The node was keep on rebooting. We went to NetApp. NetApp suggested please upgrade the VHBA versions. The first step to upgrade the VHBA was get the node out of the HA pair. high availability cluster. Once we did, once we did the update and we wanted to join the node in the cluster, what happened? It was not happening. Why? Because somebody by mistake, the winter team by mistake did the on tap deploy. So what I had to do, I had to create a new array and migrate the data using SVMDR. There was no other way to recover the thing. NetApp said, sorry, we do not have any other way. You need to create the cluster and you need to migrate the data. So that's what I did. So that's what I will discuss how to do that in my ONTAP select classes. There will be 3 classes of ONTAP select. Okay, so let me discuss some more things. Okay, so there is an important thing which is known as RAID. Okay, RAID, a redundant array of independent disk or inexpensive disk. Okay, why use RAID? RAID is basically an technology that we use for availability, high availability. High availability means fault tolerance and performance. Okay, so for that, suppose you are using only one disk, right? So that disk fell, you are gone, right? So what you are doing, you are grouping the disk together into RAID. Okay, you're grouping the disk together. Okay, you're grouping the drives together. We are aggregating the drives together. Okay, so in many vendors, storage vendors such as EMC or Hitachi, when you aggregate the disk together or the drives together, we call it as storage pool. But in NetApp, the storage pool is known as aggregates. Aggregates. Okay. So there are different RAIDs are there. In NetApp, we have RAID 4, RAID DP, RAID TEC. That is, I'm talking about on tap. Okay, and then we have E series, right? In E series we have RAID 6 only RAID 6. RAID 6 there, and there is 2 concepts: storage pool and RAID group. RAID group you have RAID 10, I think, and you have check. RAID 6 is mainly okay. So basically, normally if somebody asks you in the interview, so what are the RAIDs are supported by NetApp? You need to tell if you are using AFF or fast. If you are using ONTAP, then you use RAID 4, RAID DP, and RAID CEC. The RAID 4 protects against one disk failure, RAID DP 2, RAID TEC 3. Okay. E series RAID 6, it protects against 2 disk failure. So before discussing these things, I will discuss the algorithm. But before discussing these things, I will discuss this, the basic RAIDs. Okay. These are the things they will ask you. Okay. RAID 1, RAID 4, RAID 5, RAID 6, RAID 10. Now RAID 50 also came. But anyway, so let me just put it on charging for 1 second. So RAID 1. What is, RAID 0, I forgot to give RAID 0. RAID 0. So what is RAID 0 basically? RAID 0 basically is striping. Striping is what? You are striping the across the data, like suppose RAID 0 you are having 3 disks, right? So it will have at least 2 disks, okay? So in RAID 0 what will happen? How the storage will divide the data? So the data will be split or it will be striped across multiple blocks, and that will be that will be written across all the drives in that RAID 0 group. Okay, so the input output performance is much better. Why? Because you're writing the data. Okay, so it is much better. Okay, so what is happening? The RAID 0 is having very good performance both in read and write, because you do not have any additional overhead to keep the parity which I use for other RAIDs. Okay, RAID 4, RAID 5, RAID 6, and here, so in RAID 0 what is happening? Suppose you have 50 TB of raw capacity. So that raw capacity, you have to know about this. Okay, they will ask you what is raw capacity and what is usable capacity. Raw capacity means, suppose you have 5 drives, each 1 TB, you got 5 TB, right? That is raw. but you are using some RAID 5 or RAID 4, right? So because of that implementation, your usable capacity will be lesser than raw capacity to have the storage overhead stored, okay? Like parity store, okay? So here RAID 0, what is happening? As your data is typed across all the disks, it is not really fault tolerant. So if one of the drives in the RAID 0 group, suppose you have a one RAID group, right? It fails in that first RAID group, right? Then the data in that RAID group is lost. Okay? So you should not be using RAID 0 for mission critical applications. Okay, you should use it for non-critical applications where performance is important but fault tolerance is not that much. Like, you already have the backup, you have the time, because you know that restoring from the backup takes time, right? So your application is not like you have to be running 24/7, so you can afford a little bit of downtime. So at that time you can use RAID 0. Okay, like suppose you're using some video editing software, something, you can use RAID 0, no problem, because you're taking the advantage of your usable capacity. Okay, so let me just go here because I want to show you this. Okay, see here. Okay, it is type across. Okay, A1, A2, A3, A4. So these blocks, it can be 4 KB, 32 KB, depends. So these blocks, these are never repeated. You can see, right? So A1 is gone, then A1 is gone. You are not will be able to recover the data. Okay. Now the stripe size in NetApp 4 KB stripe size is there. Okay, so it depends on application. It depends on storage. Different storage is having different stripe size. And E series, I have the capability to change the type size. I have different ways I can change the type size depending on the application I use. In E series NetApp array, right? Suppose I am using Hadoop or I am using like Hive applications, so I can use the stripe size according to that. Okay, so you can check my E series session for that. Okay, you will this, you can see here, these are the course I have done. It's very difficult. Okay, you can see here, right? This, they have given me lot of little bit bad reading. Why? Because the session is very small. I have only discussed about these three things. I did not discuss in details. Okay, so Power Max also is in draft, so I'll be doing this. And this is like I've been sending email every alternate days to get it approved. Okay, so it's been like 1 month. I'm trying to approve, like almost like 3 weeks. Okay, so it's very difficult. So now I'll talk about the other RAID, which is RAID 1. Okay, this one is better, this looks nice. RAID 1. The RAID 1 is called as mirroring. Why mirroring? Because whatever data or whatever block you are writing to the drives, it's being written twice. What does it mean? Suppose you have 4 drives, right? Each drive is 1 TB. Then how much? The raw capacity is 4 TB, but the usable capacity is 2 TB. It becomes half. So 50 in striping in RAID 0, the usable capacity is 100% of raw capacity, but in mirroring the usual capacity is 50% of the raw capacity. So you are spending you're shelling out lot of bucks if you're implementing or using RAID 1 in your project. Okay, and the minimum drive requirement for the RAID 1 is RAID 2, and these RAIDs are not supported in NetApp. It is supported in Hitachi EMC but not in NetApp. Okay, it is not supported here because the block is in both the drives, right? It is being written twice, so the read performance will be much better, but the write performance, it has to write twice, right? So write performance will be inferior compared to the striping. Okay, and suppose this disk is failed, right? So you really do not have to rebuild the data from the surviving disk, because why? Because you already have the data, right? From there it can, you have a spare disk, it can copy it, right? And in the meantime the application use that drive, right? So you are not spending any time for the rebuild operations. Okay, it's a very simple technology. But what is the main disadvantage? That your usable capacity is 50% of the raw capacity. So that is a very bad thing. RAID 1 why we use for mission critical applications. Okay, then we'll talk about RAID 4, which we use in NetApp. Except NetApp, nobody uses RAID 4. Okay, maybe long, like 2000, before 2000 we use some RAID 4 because implementation is less, obviously some storage use, but like now aggregates is being created where your all type operating systems will be. Please rejoin as it's a free teams. Please rejoin. Please accept other people, okay? Please accept other people, don't wait for me. Yeah. So team, I have to tell you one thing. As this is a free teams, right? So just join, like if the class is 8 o'clock, right? Just join like 5 minutes before or 10 minutes before, okay? But do not join like 30 minutes before, okay? Because somebody joined 30 minutes before, right? So it got, so the free teams is having only 1 hour limitations. You understand, right? Then again we have to join. Okay? So that's why free teams is having 1 hour limitation. We can join again, it's not a problem. But that's what I was trying to say. Okay? So yeah. So you can mute yourself. Okay, let me just share the screen again. Please accept other people, okay? Don't vote for me. Okay, accepted, right? All, yeah, everybody is accepted, right? Okay, okay. Please mute yourself. You call. Okay. Now, what I'm talking about was RAID 4, right? Yeah. So RAID 4, RAID 4, RAID 4. What we have? We have a disk where we have the fixed parity. We have the fixed parity. So suppose you want to use RAID 4, right? You have 4 disks, 3 disks where you will keep the data. You'll be using to keep the data, user data, and 1 disk you'll be using to keep the parity. Okay, so this is RAID 4. Okay, so if you're losing out 1 disk, suppose you are losing out this disk, right? So you'll be able to recover the data from the parity, this parity disk. If you're losing this parity, still you have the data, right? No problem. Okay, and you can have a spare disk. Your spare disk can become the parity disk, no problem. So it will protect you from single disk failure. Okay, then you have RAID 5. So in RAID 5 what we have? The RAID 5 we have also one parity, yes, but that parity is distributed parity, not like fixed parity as we have seen in RAID 4. You can see the parity block AP, BP, CP, DP, right? It's on different drives. It is distributed across all the drives in that particular RAID 5 group, okay? So RAID 5 will require at least 3 drives. 3 drives, okay, and the data will be striped across all the drives, and you will have some XOR operations. Using that, there will be parity calculated, and the parity will be stored, or it will be spread across all the drives in that particular RAID group. Okay, so whenever you have like this parity data, like suppose your one of the drive has failed, right? So using the parity data and the surviving blocks, using the doing the XOR and XOR operations, the RAID 5 drive like group, it will be able to recreate the failed data. Okay, recreate the failed data. Okay, so that it will do, and it can withstand against single disk failure. Okay, so what is the advantage? Then you have it can protect against single disk failure. So you have fault tolerance, you have redundancy, right, high availability, and here read is very fast here, but the write will be slower. Why? Because the parity is being calculated, it is being spread, right? It is being basically spread across all the drives, right? So that's why the write will take a hit, okay? And whenever any drive will fail, right? So what will happen? You have some spare drive, right? So the data will be rebuilt and it will be copied to the spare drive, and the spare drive will become part of the RAID group, and the failed drive will become the spare, and when you are replacing the drive, you are actually replacing the spare drive. Okay, so RAID 5 is very good. Okay, so RAID 5 we normally use for database applications like Oracle, SQL. Okay, and you have to understand one thing, which is which is known as write penalty. In RAID 4, write penalty is 1. RAID 5, write penalty is 2. Write penalty, they will ask you during the interview, what is write penalty? What is write penalty? So you have to understand about few things about performance, throughput. I'll do performance analysis session during my NETA classes. Throughput, IOPS, latency. Throughputs means data transfer rate, how fast your block level data is getting transferred, right? IOPS is input output per second, read input output per second, write input output per second, total input output per second. And latency means how fast the storage is responding the request of servers. Okay, that is latency, and it is measured in terms of milliseconds, ms. Okay, so if you have some application is getting like less than 5 milliseconds, it is good. It is getting like 30-40 milliseconds, there is some problem, you need to troubleshoot. But you're getting the latency, like the server is giving you some graph where they can show you the latency. But you have to understand, as part of data center, your database, network, storage, compute, application, lot of data center components are involved. So the performance bottleneck can be anywhere. It doesn't have to be in storage. So if you check that storage latency is much better, but the latency from the application end is worse, and that means it's not a storage issue. But you do not, if you're using FC, then not only you have to check the storage, but you have to check the FC switches. I'll tell you what to check in FC switches. So when I'm talking about performance, read and write performance is better. So I'm talking about the throughput and IOPS. So now I'm coming back to the write penalty. Write penalty means for one single write in that particular RAID group, how many IOs happen. Okay, that is called as write penalty. In RAID 5, what happened? Suppose you are trying to change a data, then what will happen? First, it will read the existing data, so one read IO will happen. Then it will calculate, the parity. Then another write IO, like it will try to write the data, right? So another write IO will happen. It will calculate the parity. Then it will another write IO will happen. Okay, and then calculator, you can see read also, two write IO and two read IO. So one read IO and then calculating another read IO, and then changing the data, another write IO, writing the data, another write IO. So 4 write IOs will happen for the RAID 5. but the RAID 4 will have only one. And why native uses RAID DP and RAID TC? Because the write penalty of RAID DP is much better than RAID 6. Performance is much better. That's why they're using, because of the write penalty, because of the performance perspective, they are using this. For one IO, multiple IO does not have to happen in these cases. Maybe it has to happen. RAID DP is 2, or maybe RAID DP, I have to check. Okay, so it is having diagonal and horizontal parity. So I have to check what are the write penalty. It's difficult calculation, but RAID 4 is 1, RAID 5 is 2, and RAID 6 is 4. Okay, sorry, RAID 5 is not 2. Once again, RAID 5 is 4. Okay, so one read IO, 2 read IO, 2 write IO. RAID 5 is 4, RAID 6 is 6. Okay, RAID DP and RAID TC, RAID DP is 2, so it is much lesser. Okay, so you need to understand that because the write penalty feature only, NetApp is using this implementation of RAID 4, RAID DP and RAID TC. Okay, so let me go to the RAID 6. And I also show you how to do the IOPS calculation. Okay, tomorrow I'll show you how to do the IOPS calculation. Normally in today's world we're using SSD, right? We really do not care about it. We do not have to care. The limitation of cache is also decreased because SSD is much faster. In back in 2015, 14, 11, 10, right? So we were the storage for, for the performance of storage, we were highly dependent on cache because we're using mechanical drives. So whatever data is on cache, it is giving us faster response. But now we don't really care because the SSD is very fast. If it's from maybe going from the drive also, staging, getting the data stage from the drive to the cache, it does not matter. Within fraction of second, it is able to. Okay. And there was a survey done by Hitachi. If the data is going from the cache, it will become 4 times slower if it is going from the drive. Okay, so like that. I have one mentor who had published 16 theses for the Hitachi storage. Okay, he worked in Hitachi mentor for 18 years. He's in TCS, he's in London. So that person, he didn't marry actually, like he dedicated his thing to storage or infrastructure. So he's very good. So anyway, so in RAID 6, right, we have 2 distributed parities. So what we are doing in RAID 5, because of one single distributed parity, we are losing out some data. The usable capacity is less, right? And the RAID 6, the usable capacity is more or less because we are losing 2 drives. Like if we add these blocks, right, it will become 1 drive, right? 2 drives, right? Although it is spread across multiple drives. So basically what is happening, it is protecting you against 2 disk failure. Okay, minimum 4 drives is required in RAID 6, minimum 4 drives, and 2 drives will be used for your parity. So whenever data is corrupted, these two parity disks will be help you to protect against 2 simultaneous disk failure. Okay, if you lose 1 disk, you'll get the data back. If you lose 2 disks, you will still get the data back. Okay, here the problem is, suppose if your 2 drives fail, right, and you are replacing the drives, right, the rebuild will be much slower than RAID 5. Why? Because it has to beat only 1 parity in case of RAID 5, but it has to be built from 2 parity. It has to seek the parity, where the parity is, calculate the things, new things, write the data block, lot of stuff it needs to do. And because of 2 parity only, RAID 5 is having 4 write penalty. RAID 6, because of 2 parity, it is having 6 write penalty. Okay, but RAID DP is having 2 write penalty, which is much better in performance. Okay, and because of using 2 drives, distributed drives for write penalty, for parity, your reusable capacity is less, so you're spending more money to have the RAID 6 configuration. Okay, and then you have RAID 10. These are nested RAIDs. Even nowadays they came RAID 50 also. They have built it RAID 50 also. Okay, so here what you are doing mirroring, and you are doing striping of the mirrors, right? Okay, so you are basically aggregating the advantages and disadvantages of both striping, which is RAID 0, and mirroring, which is RAID 1, into the single system. So this is basically nested or hybrid RAID configurations. So it is giving you high availability because you're mirroring the data, and also it is giving you like speed or good better performance because you're striping the data. Okay, suppose your like one of the disk fails, right? What will happen? Because it's mirroring, right? So rebuild operation is much faster. Okay, but there is a problem. Because of your using mirroring, you're losing the half data. You're only able to use the usable capacity is only 50% of the raw capacity. Okay, raw capacity. Okay, you also have RAID 2, RAID 3, RAID 7. Okay, so the things, these levels are do exist, but I have never seen the implementation of RAID 2, RAID 3, RAID 7. I've been working since 2010, but I've never seen that. Okay, maybe long time before 2000 they were there, but now also nobody uses it. Okay, so you have to understand that. Okay, now let us go to RAID DP. Here. Okay, okay, so here what you can see, these are the blocks, right? RAID DP. So what you're having, these are the data blocks which is typed across all three drives, and these are parity blocks. You have two parity P1 Q1. Okay, so here they have implemented or they have expanded the implementation of RAID 4. RAID 4 we are having dedicated parity. In RAID DB is also we are having dedicated parity. We're using out two drives for dedicated parity, but write penalty is much better, performance is much better. So that's the reason we're using RAID DP. So in NetApp, whenever you are creating the aggregate which is known as storage pool in other environment, if you do not mention the type of the aggregate while creating the aggregate, by default it will take RAID DP. Okay, by default it will take RAID DP, dual parity, double parity. Then you have RAID TC, triple eraser encoding, RAID TEC. Okay, triple eraser encoding. Even this concept I have in storage grid, but this picture they have not given the picture. Okay, okay, so you can see here, so like you have the minimum size is 4 4 disk. Okay, so if you are using the root aggregate, right, which will have your on-top operating system, and you want to use RAID TEC for the root, right, to have better fault tolerance, so the minimum RAID group size will be 4. But if you're using for data aggregate, right, where you keep the data like CFS, NFS shares, SAN, ISCS, NVMe, all these things, right? So you'll be using the minimum size of the aggregate, sorry, minimum size of the RAID group will be 7 disk. Okay, 7 disk. Okay, it will protect against 3 disk failures, simultaneous disk failures, and also 3 dedicated parity types will be there, and RAID TC is also good. Okay, so these are the implementation we have in NetApp. Okay, you can see here. I'll tell you how to convert from RAID DP to RAID TC. How to convert? You can convert from RAID DP to RAID TC also. I will show you that in practical sessions. There are endless of things in NetApp, and we can never complete. So that's why I ask people to join for 5 years, because they will keep on learning everything, something new in every batch. With the Hitachi, that's like I get only 1%, 2%, so that's why I did not give. I stopped giving Hitachi. And storage automation is the one where I give a lot of people, like mostly people from Europe. I get. So anyway, so RAID is there, right? Yeah. Tomorrow we'll do the IS calculation. Okay. So team, do you have any questions? Any question you want to ask me, or do you want to ask me like to take it very slowly.
They'll just one question like
Any
you told
questions?
like read all the things. So on general production, what we are using?
Okay,
So
yeah. So can you please
red
repeat again what you're
means
saying?
red one, red zero, red one, everything is there. So in the production environment, what you we are using?
Yeah, yeah. Okay, okay. So it depends on the array you have. RAID DP, RAID TC, RAID
Okay,
4 are not supported in Hitachi or EMC. It's only supported in NetApp. So if you're using production, so normally you'll be using RAID
right.
DP. Normally in NetApp, RAID DP you'll be using. If you're using OnTap, but you're using E series. E series has a limitation of using RAID 6. You cannot change the RAID group.
Okay,
By pre-package it will come RAID 6. So it depends. It depends on products. If you're using Hitachi product, you'll be using RAID 5,
okay,
RAID 6 or RAID 10. Okay, it depends. In my one, I'm using RAID
okay,
6 and RAID 5 for Hitachi. For NetApp, I'm using RAID DP and RAID 4 also. RAID 4 for mission, like non-mission critical applications. Applications which are basically not critical, we're using for development and testing. We'll be
okay,
using RAID 0. For other areas I'm talking about like Hitachi, because we do not record fault tolerance, we can afford a downtime for applications where, and it depends. Suppose you are using an application which is having doing lot of sequential read IOs, right? So RAID 1 would be better
okay,
for that purpose, mirroring. RAID DP will be better compared to RAID TC because additional storage overhead will be there to keep the additional parity. You understand, right? So it depends on your performance and application type, and also your IO work like IO characteristics, input output characteristics, whether the read is more, whether the write is more, whether sequential read is more, or the random read is more. So depending on that, you need to choose the rate.
okay,
Okay, there are a lot of things are there. Okay, but as an L2, suppose you are doing the getting the L2 training, right? You really does not have to bother into that. So as an L2, what you need to do? You need to do the alert monitoring. You need to do the storage upgrade.
okay,
You need to do little bit of replications. You need to do allocations, share creations, ACL like somebody storing ACL or access control is suppose permissions error troubleshooting. Okay, node backup. All these things you need to do as an L2. L3 much more. So depends on which part of what you are trying to do, and the design is also much part of. So tomorrow I'll talk about how do we select the rate as per the IOPS criteria. I'll
okay,
calculate the IOPS and I'll show you how do you calculate the IOPS and how to define and aggregate to support that application IOPS. Okay, okay. So, do you have yeah, any
Dayal,
more questions?
can you
Anybody?
explain this
Any more
right
questions?
penalty once again?
Write penalty means for one write, how many IO will happen in that RAID group. So for RAID 5, suppose you are trying to write a data, right? So first you are trying to write a data, or maybe you are trying to change a data, right? So what will happen? First it will read the data. So one read I will happen. Then it will calculate the parity for the new data like that will do, right? So that will become one another read. Then it will write, okay? It will change the data, right, in that location. So there will be two writes, like calculating the parity and writing the parity, two writes. Reading the data and writing the change data, two like reading the data and writing reading the data is one read IO, and writing the data like change data one write IO. Calculating the parity is one read IO, and then writing the
Yeah,
new parity, that is another write IO. You understand, right? So for one
yeah.
write IO, you are having four IOs, total IOs, right? So that is four write penalty. But for RAID DP, the calculation I need to check. Okay, that is a difficult calculation because we have diagonal and horizontal parity. But RAID DP will be two, although it is having dual parity, and RAID 5 is having single parity. But RAID DP write penalty will be two, RAID 5 write penalty
Oh,
will be 4, RAID 6 write penalty will be 6. If write penalty is more, your IO impacts, your performance gets inferior. That is the
yeah,
reason NetApp has
yeah.
invented RAID 4, RAID
Per
DP, and
rate
RAID
for white
TC,
is only
which is
one.
much better, much better. RAID 4, that is how they implemented the IEEE. They have implemented this RAID 4 single dedicated parity. That's how they have implemented. We cannot say like it's the idea. Suppose somebody is creating AI, right? It's their technology. Like we're not creating, we are just doing whatever they are creating. We're explaining and working on it. They can only tell you what thoughts they have, what idea they had while they created the RAID 4. But I can tell you the reason for the RAID 4 could be single point of failure you are eradicating, right? And RAID 4 came before RAID 5. So RAID 5 is basically
Yes,
an
yes.
advancement of RAID 4. You understand, right?
So it's like
Because of
fixed.
distributed
You
parity.
say
But
right
RAID 4
penalty is
is,
fixed while it is created. Okay.
yeah, RAID 4 is fixed parity. RAID 4 is a fixed parity, but RAID 5 is a distributed parity. You have to understand for the picture. That's why I'm showing you the images. You see, here, these are all data blocks, which is types actually, and this is parity blocks, AB, BP, CP. You can understand, right? Fixed, it is in this disk only, and if it is RAID 5, it is distributed. See, it is distributed, right? AP, BP, CP, DP. You can see, right? Distributed. Simple as that. But I'll explain the RAID DP part, right penalty part. It's a little bit difficult for me. I also forget. There was a journal there. Not many people will know that, but I know that RAID DP is right penalties too. Calculation would be, I am thinking, suppose you're writing something, right? So parity, I need to check. Okay, I need to think why it is two. It's difficult to
And
tell, but I'll check later.
and
Okay.
Dayan, like, yeah,
If they ask you the
one thing,
question, if you
like, I
tell,
mean,
yeah, if you tell
which
RAID 5,
drive
RAID
is
6, right?
good
Yeah.
at reading and for reads, and one which one is for writes? That I just wanted to know with exact.
No, 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 nothing like that, nothing like that. See, these are blocks basically. These are not like one drive is dedicated for read, one drive is dedicated for write. No, no, nothing like that. These are blocks. If you want to read the data, you'll be sick from here. If you're using mechanical drives, your header will go to that platter and it will find out that block.
Yeah, yeah, I think, yeah,
Okay, this is
read.
called
Which
as
read is
seeking
good for
time.
read, and
Okay, so
like read 5 is good for, yeah.
okay, which date is good for read? Yeah. RAID 1 is the best for read because it's mirroring. It just has to, it is based for read. And the writing is based for RAID 0. But you do not have fault tolerance. RAID 0 is the based for writing. And RAID 1 is based for reading. And you also have RAID 50, which I have never used. Do you guys know where RAID 50 is
When we
used?
compare like RAID 5 and RAID 6, which one is
Do you know?
good for writing and which one is good for reading? RAID 5, RAID 6.
RAID 5 is better in writing and reading compared to RAID 6. But if we're talking about fault tolerance, then RAID 6 is better. Means it can withstand against two simultaneous disk failure. But RAID 5 only one. Okay, and you have RAID 50. But I have never used RAID 50. Have you guys? Are you guys using any array or any storage product where they're using RAID 50?
No,
Infinidat or SEP, CPH?
no.
Some, no, right? Even I also did not see, but they have. I think recently they created this. Okay, RAID 50. Maybe it's in between 2 to 3 years they created RAID
So one more,
50.
one more thing I want to confirm. Like, so
So they have
RAID
created
6,
like they.
that two parity disks will be there, and that parity is spread across. And in RAID DP, two separate parity drives, right? That's the only difference, right?
Yeah, yeah. In ADP, dedicated parity drives, two dedicated parity drives. RAID 6 parity is there, but it is distributed across all the drives in that RAID group. A aggregate can form with multiple RAID
Yes.
groups. You understand, right? Your storage pool in Hitachi or EMC can have multiple RAID groups, but you do not mix. Like in storage pool, you do not have RAID 5 and RAID 6 in the same RAID group, but you might have one thing, like you have the RAID 6, right? So you have 14D plus 2P. What I mean to say is that RAID 6, 14D plus 2P, and 7D plus 2P. This is called as mix rate, okay? 2P. So you are using 14 disk to have it to keep the data blocks, and 2 disk for to keep the parity blocks, and that is creating a one parity, and then you have 7 disk for the data and 2 for the parity, that is another parity rate group, and both these things are part of one
I
storage
think
pool. Okay, that is
Di-
possible, that is okay, that
Dayal,
is
this is
okay.
like
Then this is called
14D
as
plus
mixed
2P, and
rate,
the other
mixed
one
rate,
is like 6D plus 2P.
mixed rate.
Yeah, is that or 7D plus? Okay.
7D
Generally,
plus 2B, 7D plus
yeah, that
2B.
will be like multiples of 4, na? That's why I'm
Rate
asking.
6. No, no, these are same rate group only, but configuration is different. If you're using 14D plus 2P, that means for 14 days you're losing out of 2 disks, and 7D2 plus 2P means for 7 days you're losing out 2 disks to parity. That means the usable
Yes, yes.
capacity is more here, right? You understand, right? So we are using this, but this sort of configuration we do not use in NetApp. And you cannot mix, like you have a storage pool where you are having both RAID 5 and RAID 6 in Hitachi, and similar to NetApp also, you do not do that. Okay, same RAID group we use, same RAID group in
Okay.
aggregate,
And
not
like
different
in the
RAID group.
beginning, when you told like different types of storages,
Okay.
that HCI, I think, can you just once again brief on that?
Yeah, it is like hyperconverged. So that means you need to check in Google, right? Nutanix, Simplicity, VBlock, FlexPod. You'll get the storage, compute, network, your rack,
Oh,
everything will come together. Okay, it's in a single box. You'll get it. In single rack, you'll be able to mount it. So it's kind of like pre-packaged solutions. I'll tell you one thing. One of my student, Mahesh, he's using Nutanix, but he has connected NetApp to Nutanix, and he's using it there. But he's using SDS also. I don't know. Ask him. I think probably I'll probably ask him how did he like what configuration he's using. But he's actually using the software defense version of NetApp in Nutanix, and he got some error and he came back to me. Okay, so I told him what to do. So the problem is, what happened was, when he tried to create the on-tap cluster, he got an error. Why he got an error? Because for every node that you create in software defense storage array, minimum 1.5 TB is required as per the latest on-tap select version prior to 2017, not 17, I think 19. We only were able to do using 500 GB, but newer versions requires more capacity and more limitations, because more disk you buy, your profit will, like the vendor will do more profit, right? So that's why they are doing something. They're very smart. And for the software defense project, what you need to do is you need to create the license. Like license means for the capacity wise. Okay. Okay. So guys,
and
I'll stop the session
yeah, in
here. Last
SDS, like,
question. Do you
is
have
that for
any question?
only
Any
software
last
defined
question?
storage, only NetApp supports, or how it is like?
No, 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 no. SDS is, every vendor is having SDS product. In Hitachi, we have HCP for Cloud Scale.
Okay,
That is
so
HCS
like,
product name.
yeah.
HCP for
So
Cloud Scale.
Dayal, you said like for
And here,
SDS, like, I mean, if we have SAN, and if we don't want to invest on NAS, you said like we just need to install a software at which where we have to install the software, SDS.
OVA file
Okay,
on
so
VMware,
like
VMware,
in that case,
either
like
VMware or Nutanix.
all the ESX, like all the servers we have to keep on installing that, right? For using that SDS.
Nothing like that. So see,
Okay.
the first
Yeah.
one we'll install is the on-tap deploy, which will be VM. Okay. In NetApp, we have a concept of intercluster switches, using which the cluster heartbeat communications, everything will go out, okay, and the communication from one node to another node will happen using the intercluster switches. But in on-tap select area is software defined, there is no intercluster switch concept. The on-tap deploy will act as intercluster communications, so it will send the heartbeat. So I will be creating the on-tap deploy from the OVA template, which I will download from the NetApp support site, and from the on-tap deploy only I'll be creating the NetApp cluster. So these things will be done in the L3 sessions, okay? So don't worry about it. I will discuss that.
Okay.
I'll do from
Thank
both
you.
CLI and GUI. CLI and GUI. I can check my earlier session also, so you can check here. I don't know why it's slow. My internet is good actually. Actually, I've cut down the towers, okay?
Your
Initially,
voice,
like three
your
months
voice is
before was
breaking.
already done training, right? So at the time, I used to do
Yeah,
like
now
12 hours
it's
training
good.
and I took like 40 hours
Can
training.
you
But
repeat
now
again?
all those things, voice is breaking. Yeah, maybe. Mhm. So you can see here, right? So you just need to check the syllabus, okay? And you see somebody is okay. Happy birthday. Somebody is saying, okay. So you need to see, okay, the troubleshooting, everything I will discuss, okay, and on tap select. So here I will discuss this, the issues. And one of my student Gautam, he works in USA, okay, he got an issue in on tap select, for which I have given him some solution. Okay, so the thing is, although I help people support something, but I'm not taking the money for the support, right? I'm giving you training. But why I help people? Because it's okay, it's like constructive, work, right? But it's not like that you should be like you got an P1 and you're calling me when they are, please join. Not like that, okay? Because I also, you cannot do that. So you also have to, you can ping me, I'll give you the solutions like what you need to do. And somewhere like some things which cannot be done, I'll ask you to go to the NetApp. So like this, okay? So here, and how many of you have metro cluster in your environment? Metro cluster? How many of you have metro cluster in your environment? Anybody? No, right? And one thing you need to do, go to the Naukri and just type NetApp job 10 years, 15 years. You will see that 7 MTT is also required, especially for the NetApp company interview. There are two ways we do 7 MTT, CBT and copy free, CFT. Copy free transition and copy based transition. So both I teach. And a lot of other things are there anyway. So, and these optional session were not done. Optional session I do not teach live, okay? I will just create the session, upload it, okay? Because then it will take 5 months to complete the session. So this optional session, okay, like ransomware protection, e-series that although I did it this time, all array, snap log, multi-factor verification, okay. And one more thing, after my training, you'll be prepared for the NCDA certification. You can go ahead and give the NCDA certification, data certified data administrator certification, okay. Okay, so yeah, so we'll wrap the session. And before we wrap the
Yeah.
Hi
session,
there. I'm
Rohit, are
So
unable
you
to
able to
access it.
access
That's what
the
I pinged. Just
are you able to access the videos?
Banu here. I'm able to
Okay,
access,
so
but
anybody who's not able to access the
just
videos,
the screen is not coming. Can you just check? Yeah.